cousins today. So, most people are right-handed, and even the right eye is dominant for most people. In a study in Nature 2003, I'm assuming that's German biopsychologist Unar Guntuken, conjectured that this tendency to turn to the right manifests itself in other ways as well. So he studied kissing couples to see which side they tended to lean their heads while kissing. Now,
Creepy at all.
how do you do this?
God,
It's going to have to be in secret, right?
Yeah.
Okay, well, this isn't creepy.
No, not
He
at all.
and his researchers observed 124 couples in public places, such as airports, train stations, beaches, and parks. For each couple observed, the researchers noted whether the couple leaned their heads to the right or to the left. Okay? Anybody want to give us an example of how that's done? So,
I think I'm in between something here.
No, it's okay.
So number one, what are the observational units and the variable of interest?
The kissing couples.
So the kissing cousins.
And then
So I assumed that this was done in a park in Cleveland, which is why I called it Kissing Cousins, but I guess it was in Germany, so maybe I should rename it. So the observational units are the people kissing each other. What are the variables?
Which way they
left
jump.
or right?
Which way do they turn? Do they turn right or do they turn left? And you have to turn, because otherwise your nose gets in the way.
And then
Right.
you do the full like groove.
Yeah. All right.
Skill shoot.
So identify the parameter of interest. What's the parameter?
The long-term percentage.
The
Long term.
the long-term percentage of how often people turn to the right. Okay. So calculate the statistic. So what is our statistic in this case?
124.
Oh.
Something out of 124.
Something out of 124. In this next paragraph, it says 2/3.
People have a dog
Oh,
right.
so maybe I should put that up there. Okay. So the statistic is.
80 out of 124.
Where did you see that?
That's at
Yeah,
the
very
bottom.
bottom of the second
Very
paragraph.
bottom of the second paragraph.
Oh, okay. Well, that needs to be fixed. Okay. So, yeah, I'm gonna have to fix that. So, Dr. Gunturken noted that about 2/3 of the people have a dominant right foot or eye, and conjectured that people would exhibit a similar tendency of right-sidedness when kissing. Suppose you want to investigate whether the sample data provide evidence that the probability of a kissing couple leaning their heads to the right while kissing is different from 66%. How can we test whether there is a statistically significant evidence that the probability a kissing couple turns to the right differs from 2/3? So in your sample, you observed 80 out of 24 couples leaning to the right. So this should be 80 out of 124. What is that as a percentage?
Uh, 64.5%.
Okay, so that's our statistic. Okay, so what is the null hypothesis? H naught says pi is equal to
2/3, right?
66.6
Seven.
repeating percent. And the alternative? AJ is pi is,
Greater than.
Not equal to.
where do we get the not equal to from?
Oh, it says is different from.
Yes, in this paragraph up here.
No, actually, it's the second one.
Oh, was it in the second paragraph?
Yeah, it's right before the number.
Read this.
differs from 2/3. So not equal to 66.6%. So this is a two-tailed test. So go into Rossmann 1 proportion and simulate the p-value.
Oh my gosh. P-value is huge.
Alright, so our probability of heads is 0.66. Those are Y's. 6667. Number of tosses, do it again. 124. And I'm not going to run samples. Instead, I'm going to use the normal approximation. Okay. And then our number of successes was 80. And we want to shade
Both sides.
both sides. So I get a p-value of 61%.
The conclusion is that's probably pretty close. Yeah. Do you accept H?
What's that?
What? Mine's long.
Oh, so
Click.
this.
There you go.
Yeah, that
Guess you have to
happened.
click the second one. Yeah.
That happened yesterday to some people. So we ended up with a really big p-value. We ended up with 61%. So, number 6, what is your conclusion?
We accept the null hypothesis.
So if my p-value is 61%, that is greater than 5%, which was the threshold that we decided to use. And with a p-value that large, we are going to accept the null hypothesis, which suggests that a 2/3 probability or a 2/3 parameter is accurate. Now, do we really think that 2/3 is right? No, we just don't have any information that suggests that 2/3 is wrong. And once again, we'll never know. There's no way to figure out the parameter in this case, because you would have to talk to every person that has, is currently, or will ever live.
So it's like Schrodinger's cat exists in a bunch of
Yes.
statistics.
Yes. It is Schrodinger's cat, only.
Opening the box requires talking to everybody on Earth.
Right. I like that. Okay, so oh dang it. We didn't do simulation. I gave up on simulation this year because we don't need it. So would we get a different number if we used the simulation?
Probably.
Slightly,
Yes.
but
So
not enough.
if I type in 1,000 and draw the samples, I get a p-value of 64%. So either way, we're going to reject the null, whether you do the theory-based approach or the simulation approach. But the simulation approach is never going to be perfect, and because of that, we don't really even use it. The book introduces the simulation-based approach to help you understand where those numbers are coming from, but we are just going to use this normal approximation number. Okay.
So then,
So,
what?
this one was 63%, and this one is 61%. sorry about that. But does that change our results?
No.
No. It's the same results.
So then what determines if we should use simulation or theory?
We are eventually just going to use theory.
Okay. So then are we just not gonna touch 7 or 8?
Yeah, that's fine. So, should we use simulation or theory based on the situation? Theory. Oh, 7. Yeah, I don't know. I personally just gave up on simulation. Okay. So, I want you guys to do the same thing, but now another group claims that 74% of people lean to the right when kissing. So that's a different parameter. So now run the same tests using your statistic of 80 out of 124. Use a theory-based approach. And then answer questions 11, 12, and 13.